When we have cosines and sines multiplied together, we want to focus on the one that has an odd exponent. So sine has an exponent of 3, so we're going to focus on that. We want to break it out in groups of sine squared, because we can always change sine squared x to 1 minus cos squared x. Remember this one, our Pythagoras identity. So sine squared and cos squared are always good to have around. Sine x on its own, not so good. So that's why I'm going to kind of break that out. So I'm just rewriting the integral here as cos 4x times sine squared x times sine x dx. Haven't done anything, I've just broken that out. Now we should be able to change our sine squared x, and if you had more than just the one, you would do it for all of them. Change our sine squared x into 1 minus cos squared x. This is great because it's going to set us up perfectly for u substitution, where u equals cos x and du equals negative sine x dx. This will allow us to get rid of all of our trig functions, and we'll just be left with some u's that we can easily integrate. So let's see what happens. Cos 4x becomes u to the 4 times 1 minus u squared, because cos x is u. Then we've got sine x dx here, but du is equal to negative sine x dx. So I'm going to say negative du is equal to sine x dx. So I'm now going to just replace this with negative du. Can bring the negative 1 out front because that doesn't impact. Multiply through the u to the 4. U to the 4 times 1 is u to the 4. Minus u to the 4 times u squared is u to the 6 du. Now it's a really easy integral. Negative u to the 5 over 5 minus u to the 7 over 7 plus c. And I should have a bracket around that, otherwise I'll miss a negative. Last step is substitute back out the u for cos x, right? Don't forget to do that. When we're given a question in terms of x's, can't leave our answer in terms of u. So the answer will be negative cos to the 5x over 5 plus, because I'm multiplying this negative through to the other negative, plus cos to the 7x over 7 plus c. Don't forget the plus c because it's an indefinite integral. The important piece here is whenever we have a bunch of cosines multiplied to a bunch of sines, isolate one of the sine or cosine out from the one with the odd exponent. So focus on the odd exponent, break one of them out, change over the other squareds, and substitute u for the one that you didn't break out. Hopefully that was helpful. Thanks.